Spindle probe calibration is required to minimize the amount of mechanical, electrical and environmental errors which would otherwise be included in the measurement data. Once the initial setup has been completed, the automatic calibration cycle can be run at intervals that suit the machining process requirements. One method for calibrating the spindle probe is to use a dial test indicator, a ring gauge, a tool of known length, and a ground engineer's slip. Begin by securely mounting the ring gauge to a fixed position on the machine tool table. The true diameter should be known for the bore size. Next, the X and Y position of the centre of the ring gauge must be determined. This can be found by setting the spindle roughly over the centre of the ring gauge, then mounting the dial test indicator on the spindle nose. Adjust the dial test indicator so that it remains in full contact with the ring gauge surface whilst being rotated by hand. Manually jog the machine to reduce the X and Y errors of the spindle centre position in reference to the ring gauge. The error appears on the dial test indicator. The error should be corrected to be as close to zero as possible. Ideally, better than 5 microns. The X and Y machine encoder positions should be recorded at this point. To find the Z position of the ring gauge top surface relative to the spindle nose, a comparator or tool of known length should be used. This is usually required due to the travel limitation of the machine spindle. A tool of known length is required as the comparator. Its length should be measured on the machine so that the length is accurate for that spindle. To determine this length, the dial test indicator should be mounted on the ring gauge and the spindle nose jogged in the Z-axis to make contact. Make a note of this position. The comparator, or tool of known length, should then be loaded into the spindle and jogged in the Z-axis to make contact with the dial test indicator. The difference in Z position equals the tool length. This value should be recorded. The spindle, loaded with the tool of known length, is now positioned close above the ring gauge surface. The slip gauge length is required at this point. The tool of known length is now jogged in Z- in small steps above the ring gauge. Slide the ground engineer's slip under the tool until the tool has been jogged too far. The tool should be wound back up again and the feed rate reduced, again using the jog and slide method. The jog and slide method is followed until the slip can no longer be moved under the tool at the lowest feed rate possible. The machine encoder position should be recorded at this point. The thickness of the slip gauge and the length of the comparator or tool of known length are added to the position recorded from the machine Z encoder. This gives the relative surface position of the ring gauge to the spindle nose or machine datum. Now the user has the precise X, Y bore position and Z surface height of the ring gauge to the machine datum. The spindle probe should be loaded into the spindle. The calibration cycle finds the trigger position of the stylus at various angles and axis directions. It removes many of the mechanical and electrical errors which would otherwise be included in the measurement data. To optimize measurement cycle time, the back-off distance can be adjusted in the macro program. Renishaw macro software includes an automatic calibration cycle to remove any errors from the stored position in X, Y and Z axes. The user calls the macro program, then positions the probe in X, Y and Z to the center of the ring gauge in the previously recorded positions. The stylus accurate ball diameter and the ring gauge diameter are now manually loaded into the calibration cycle. The calibration cycle is then run. Multiple angle positions of the ring gauge are measured. The ring gauge diameter is measured in the X and Y axes. In this way, rotational errors of the stylus are calibrated out. Finally, the Z position is measured on the top of the ring gauge. You should run the calibration cycle periodically to ensure that any environmental changes are calibrated out of the probe measurement data.